Welcome students to this screencast where we are going to be looking at more graphing of linear functions. If you recall, in the previous screencast we gave a little background information talking about the slope-intercept form of a linear function. So this linear equation represents a linear function y equals mx plus b, where m represents the rate of change or the slope, and b represents the y-intercept. All right, and then we also looked at standard form, ax plus by equals c, and I said I'd explain that more later, and we will do so later. We also looked at setting up a input-output table, where our inputs are represented here on the left-hand side, often represented by the variable x, and our outputs on the right-hand side, represented often by the variable y. And we talked about the domain x being our inputs, range y being our outputs. One thing I didn't mention earlier was rate of change being the slope. Slope is calculated by the change in our y values divided by or over the change in our x values, often called rise over run, and which is often also looked at as our second y coordinate, take away or subtract our first y coordinate, that's the change in y, and our second x coordinate minus our first x coordinate. So that's what this change in y, change in x means. y2 minus y1 divided by x2 minus x1. Just wanted to go over that and make sure we had a little bit of an understanding, and we'll practice this later on, but how to look at slope and how to determine it. Let's do a couple more graphings of linear functions. If you'd like to pause the video now, go ahead and do so. I'm going to go ahead and create an input-output table for this linear function. Notice here's my slope of 3, and notice there's my y-intercept of -5. So let's go ahead and create an input-output table. Again, if you want to do this one on your own without seeing me do it, go ahead and pause the video. So here's our input-output table, my x domain on the left-hand side, my y range on the right-hand side. I don't have a fraction right here or a ratio where the numerator is less than the denominator, so I just don't have to pick any particular values that are going to be easier for me. I'm just going to use one negative value, 0, and one positive value. I always use 0, that way I clearly graph my y-intercept. I said earlier my y-intercept's -5, so I'm going to go ahead and put it there, and I think you'll see why in just a moment. So let me substitute -1 into this expression here. So 3 times -1 minus 5, well, 3 times -1 is -3. Take away 5 more, that gives us -8. All right, if you notice, my coordinate plane doesn't go down to -8, so I'm going to have to extend this just a little bit. And let's see if I can draw a line that's a little better than that one. I'm actually going to use this line tool here. And we are going to extend our axis. So there I've got 6, and I'll go to -7 and -8. Alright, so -8 is our output when our input is -1, and I'm going to use a lighter color here to go ahead and graph that so you can see it. And excuse me, notice our input value was -1, so that's -1, -8. That's going to be that value right there. I'm going to use a darker color so that we can see that. There it is. 0, when you input 0 into this expression, you get 3 times 0 minus 5, which is 0 minus 5, giving us -5. Remember, I told you that my y-intercept would be -5. There it is right there. And when I input 1, let's use a different color here. 3 times 1 minus 5, well, that's 3 minus 5, which is -2. So I'm going to graph input value 1, go over 1, down 2. And if you remember, these are all ordered pairs in this input-output table. -1, -8, 0, 5, and 1, -2. So I graph those points. Now let me connect them. They are collinear. They lie on the line y equals 3x minus 5. Let me go ahead and graph that quickly. And that does a pretty good job of going through those points. Notice I have arrows on the ends of my line there showing that this goes on forever and ever. My domain is actually infinite. I can input any values I want into this function, and it's going to output some unique value. Okay? Hopefully that makes sense to you. We've done quite a few of those. If it doesn't, come and see me. But let's take a look at a special function here. If you notice in the last video I talked about x equals a number, and that is not a function. That's a vertical line. Well, I want to talk about the graph of this function. Now this is a function. If we create an input-output table for y equals 4, well, my y value doesn't change. So I'm going to put 4 in 3 times here. It doesn't matter what my input is. I'm going to, again, use a negative, 0, and a positive number. So I'll just use -1 again, 0, 1. You'll commonly use numbers like -2, -1, 0, 1, and 2. Just these are easy numbers to deal with often, especially if you have a friendly rate of change. Okay, so input value -1. Well, what's my output? Well, my output is fixed at 4. So it doesn't matter what input value I place into this function, my output is always 4. So input of 0, 4. Input of 1, I still get a 4 out of this function. So let me go over and graph these points. Remember, these are ordered pairs. So I have -1, 4, 0, 4, and 1, 4. Go ahead and plot these. -1, 4, 0, 4, and 1, 4. And what do you notice? Hopefully you notice this is forming a horizontal line. This is the horizontal line y equals 4. No matter what my input value is, no matter what my x value is, my output is always 4. So I could put in 1 million into this function. The output is still going to be 4. Notice using integer values for my input, I'm placing some dots here. No matter what integer I place into this function, it results in an output of 4. This is a function. So this, unlike our vertical line, is a function. This passes the vertical line test, and this here results in a horizontal line. So I want us to, since I introduced vertical line in the last video and said that was not a function, I wanted us to look at a function that results, or its graphical representation, as a horizontal line, so that we understood the difference between the two. Notice, if I were to draw vertical lines through this graphed function, the vertical lines would only pass one time. Therefore, this passes the vertical line test, and this is a function. If you remember, when I had x equals 4, that was not a function. But when I have a situation where y equals 4, this is a function. And that does it for this screencast. I'll catch you later, students.